All right, going on now to example number 6. We're going to be solving now quadratic equations by a method called completing the square. And completing the square is a very interesting concept, and there are many steps involved. And I'm going to try to do a thorough explanation so you're understanding how these things work. So I'll do a number of examples here. So maybe it would be best if you want to just do this, then go ahead and write down all the steps first. So there are 6 steps in there, and you can kind of write them all down right here. So maybe if you want to pause the video, write down all 6 steps. I mean, they're going to be right there as I do the problem on the left, but just go and have those all written down. We're going to be referring to these 6 steps when we're solving our quadratics by this method called completing the square. Okay? All right, and so here we go. I'll explain what it means to, why is it called completing the square here when we get to that part here in a minute. So let's just go ahead and dive into our problem here. Okay, so here we have our quadratic, okay? And again, when it says solve, the context is really, what are we finding? You know what we're finding right there. We're finding the X-intercepts, right? So that's really what we're finding, but just by another method. Okay, because we've learned 2 methods so far, right? We've learned like how to solve quadratics by factoring, and we've solved quadratics by the square root property. Square root, not square roots. Okay, right? So now we're going to add on a third method now by completing the square. All right, it's a little lengthy, as you can see there. You're like, no, mijo. All right, no, it's a little extensive here, but I think once you get the hang of it, it does kind of flow rather nicely. So let's go ahead and check this guy here. All right, so we have x squared minus 2x minus 10 equals 0. All right, I want you to notice this here is that I said steps to completing the square, and then notice how I wrote the quadratic like this. It's just a general form, ax squared plus bx plus c equals 0. Okay, this is when you know that you're going to use completing the square, or we usually solve quadratics by completing the square when it's written in this form, ax squared plus bx plus c. Okay, like if you come up here, what's my a term? It would be 1, right? There's a 1 in front of the x squared, so my a here would be 1. Over here, bx. So what's my b term? Well, it would be -2, right? And then what would be my c term? Right here, so -10. So see how the general form matches our example right here. X squared minus 2x minus 10 equals 0 is in this general form. Okay? So step number 1. Write the squared term as a equals 1. Okay, so the squared term means this, so write it as a equals 1. So we want our a to be 1. We want the a to be 1. Well, in this particular example, I want to start with something a little simpler. A is already 1. I mean, we can see that, right? Look, a right here, a is right here. What ghostly number is in front of x squared? There's a ghostly 1. All right, so a is 1. So step number 1, you can check off because we have that 1. So bing. Step number 2, write the equation so it looks like this. X squared plus bx equals c. Okay, so here's x squared. Here's our bx, but then notice how the c is on the right side of the equation. So basically all step 2 is write your c term and put it on the right side. Okay, and we mathematically do that by adding 10 to both sides. So now I have x squared minus 2x equals 10. And notice that, okay, I mean, this could be a negative bx. This could be a negative c. The sign is not what's important. Is that the terms, the x squared and the x term, are on the left side. See that there? And the c term and the c term right here are on the right side. That's what's important in step 2. So it looks like we have that all satisfied. So, bing! Step 2 is done. Now here we go, step 3 now. We're going to divide b in half and square it. this is our special number. Ooh, I wonder what the special number is. Well, let's see here. So let's take our b term, right? Remember, our b is a number that's next to x. So our b is -2, right? So this is now kind of like on the side of our paper now. So we take our b term, and it says divide b in half. So that's the same thing, divided by 2. So -2 divided by 2 is -1. So I did the first part. It says divide b in half and square it. I need to square this whole number now. Square it. -1 squared. -1 times -1. Uno. And this is a special number. Aye. Cool. So I'll put a little star right here because you're special, little dude. Okay. That's a funky looking star. Now it's like a little dot now. Oh well. Okay. So step number 3. Bing. There we go. Now, add the special number to both sides of the equation. Okay, I'm going to take our special number 1. I'm going to add it to the left side and to the right side. So watch this. X squared minus 2x. I'm going to go ahead and add 1. I'm going to add 1. I'm just going to emphasize with my black there. And I'm going to go ahead and add 1. Does that satisfy step number 4? Add the special number to both sides of the equation. Look, I added a 1 on the left side and I added a 1 on the right side. Right? C. So that's step number 4. Bing. Okay, so why was I'm gonna stop right now. I'm not gonna do 5 yet, but so what was so special about this number? Okay, well, notice how I said that I was going to explain to you what completing the square means. All right, so really, this 1, okay, this special number, it's not always 1, but in this case, the number 1 is special because, okay, watch this now. This is so cool. When I added 1 to the left side, this is a special type of trinomial. It's a special trinomial now. And you actually learned about these kind of trinomials in the last class, and Math 95. I believe it was chapter 6. Do you notice what kind of a trinomial this is? And this will always happen, by the way. This cool trinomial always happens. That's why it's our special number here. Does anybody remember what that little guy is called? Well, this guy right here is called a perfect trinomial. Okay, meaning, and a perfect trinomial was this. If you remember, it was a plus b squared, which was a squared plus 2ab plus b squared, or the other perfect trinomial was a minus b squared, which was a squared minus 2ab plus b squared. Now, hopefully I'm not going too nerdy on you right now. I'm just kind of review from chapter 6. But okay, this right here is a perfect square trinomial. Okay, it's one of our perfect trinomials here. Oh, I guess I should put square right here. It's a perfect square trinomial. Meaning, check this out right here. Okay. If you factor this right now, okay, if you factor this, okay, and you can do that by using the cool judo method, right? Remember how we do a little x here, put the 1 on top, put the -2 on the bottom, okay? Now we need 2 numbers that multiply and give us 1, and you add to get -2. Well, wasn't that just -1 and -1, right? -1 times -1 is +1. -1 plus -1 is -2. And that means if I write these out as my 2 factors, I get x minus 1 times x minus 1. But that right there is just x minus 1 squared. So notice that it was in this form right here. See how it's a minus b squared? X minus 1 squared. Okay, so if that was like, oh, dude, man, you're going like super nerdy on this right now. All right, so basically all I'm saying is this. This is what I'm really trying to say right now. That's like the background. Here's like straight to the point now, like no joke right now, okay? The point is this, is that in step 5, it says factor the left side. when you add this 1 right here, it's always going to factor to be either an a plus b squared or an a minus b squared. It will always factor like that. Always, 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 always. That's what's so special about this number. It creates what we call our perfect square trinomial. So that means that when you factor this guy, it should be written like this. Okay, that's the whole point now. You have to write it in a perfect square trinomial form, okay? That's the whole point there, is when we factor the left side, that's step number 5, factor the left side. Make sure you factor it like this, x minus 1 squared, not x minus 1 times x minus 1, okay? So I'm going to erase all this right here, but you have it on the video. You can pause it in if you want to do that there. And that's what we're going to do then, all right? Okay, so let's go back now to step number 5, and let's do it now. Okay, step 5, factor the left side. Well, I know the left side is going to be x minus 1 squared. And let me let you in on a cool little secret right now. The shortcut to factoring this really, really, really fast is this. Okay, watch this. It's going to be x minus some number squared. And I know it's going to be minus because of this right here is a minus sign. And the way that you get this number right here is you divide this number right here divided by 2. You always do that, and then you're going to get 1 right there. Okay? That's the cool shortcut. It always works. But if you're like, oh, I don't know about that, dude, like I want to do it the long way just because you like long stuff, then you can do it, by using the judo method or, by factoring it all out. But you will always get x minus, and then you divide that number by 2. If this was a plus sign, it would be x plus, and then divide that number by 2. So, okay. Hopefully I'm not going too nerdy, because sometimes when you go too deep, you just kind of lose what the heck are we doing here? But I'm going to do more examples, and I won't get too hairy there. 10 plus 1 is 11. Hey, doesn't this problem look just like the ones that we were doing before now, when we have to do the square root property? See how it built right there, where you learned that stuff. Now we're going to use it now. And so now it just becomes one of those problems that we were doing before. Okay, so let's get rid of the square by taking the square roots. And I get x minus 1. The square and the square root cancel, equals plus or minus radical 11. Can we break down square root of 11? No. Good job there. Yeah, so we can't take the square root of 11. So that means we're going to add 1 to both sides. Add 1. And we get x equals 1 plus or minus radical 11. And we can't simplify any of this, so we can leave it just like that.